Fundamentals of pressure, problem solving. Problem number 1. A tank contains 1 meter of water and 0.5 meter of oil with a specific gravity of 0.8. Find the absolute pressure at the bottom of the tank. For pressure problems, you may either write the given or you may illustrate it that best show the given quantities from the problem itself. So for problem number 1, as you can see on your screen, there is an open tank exposed to the atmosphere which contains two fluids, oil and water. The problem requires for you to solve the absolute pressure at the bottom of the tank. To be able to solve this, you first have to know what the absolute pressure contains. So since the vessel is exposed to the atmosphere, the absolute pressure will be the sum of the gauge pressure and the atmospheric pressure. Using as reference, the oil surface or the top of the oil surface only has one pressure affecting it, and that is the atmospheric pressure. While the bottom of the tank, where we can solve the absolute pressure, has three pressure affecting it. And that is the atmospheric pressure, the pressure due to oil, and the pressure due to water. So, the atmospheric pressure are actually constant values which was given to you in the PowerPoint presentation prior to this video lecture. So we will only have to solve the gauge pressure by using the focal point at the top of the oil surface. And that is here, the line right here. So from this, you will have to go where the fluids change. So that means it is the interface between water and oil, and it is the line that is shown to you right here. So the hydrostatic pressure due to oil starts from the tip of the surface up until the interface between oil and water, and that can be solved using the equation specific weight of oil multiplied by the height of oil. Again, since the specific weight of oil is not given, formula expansion will be required, thus replacing specific weight by specific gravity of the oil multiplied with the specific weight of the reference fluid, which is water. Upon substitution, specific gravity of oil multiplied by the specific weight of water multiplied by the height of oil, which give us the hydrostatic pressure of 3,124 Pascal. Since we are done knowing what is the effect of oil, we are already in this part, or the interface between oil and water. Since we need the absolute pressure at the bottom of the tank, we have to know the effect of water or to the hydrostatic pressure at the bottom of the tank, which we can solve through using this formula. Specific gravity of water multiplied by the specific weight of water multiplied by the height of water, thus giving us the equation 1 multiplied by 9,810 Newton per cubic meter multiplied by 1 meter, thus giving us hydrostatic of pressure due to the water surface as 9,810 pascals. By applying the second law of Pascal, also known as the pressure transmission law, we add hydrostatic pressure when going down fluids, which means at the bottom of the tank, since there are three pressures who are affecting it, we have to add all of them to get the absolute pressure, which means the final formula for the absolute pressure is given in the screen, which is the atmospheric pressure plus the gauge pressure due to the oil surface plus the gauge pressure due to the water surface, which were solved prior getting this final formula. Finally, adding 101,300 Pascal plus 3,924 Pascal plus 9,910 Pascal gives us the absolute pressure as 115,034 Pascal or 115.034 K Pascal or kilopascal.